So here we shall explain the concept of the inverse of an element with respect to a given binary operation with an example. So the inverse of an element is defined as, so given a binary operation, star, which maps A cross A to A with the identity element E, in the set A, um, an element A which belongs to the set A is said to be invertible with respect to the binary operation star, if there exists an element B in the set A such that A star B, that is equal to E, which is equal to B star A, and B is called the inverse of A, and is denoted by A inverse. So we can understand this by one example. That is, if it is asked to show that minus A is the inverse, um, of A for the addition operation, plus on the set R, and 1 by A is the inverse. 1 by A is the inverse of A, which is not equal to 0 for the multiplication operation. The multiplication operation N2 on the set R. So now we can understand. So therefore, as we know that minus A plus A, that is equals to 0, and that is also equals to A plus minus A. And since we know 0 is the identity element for the addition operation, 0 is the identity element for the addition operation. So I can say 0 is the, no, sorry, minus A is the inverse of A for addition operation. Minus A is the inverse of A for addition operation. And similarly, as 1 by A into A, that is equals to A into 1 by A, which is equal to 1. And since 1 is the identity element for the multiplication operation, and 1 is the identity element, 1 is also the identity element for the multiplication operation. So 1 by A is the inverse of A for the multiplication operation. So hence grouped. So hope you have understood. But here, if we say that the addition operation we are applying on the set n of where n is the set of all natural numbers, and also if we apply the multiplication operation on the set n of natural numbers, then minus a is not the additive inverse. Minus a is not the inverse for addition, and 1 by a is also not 1 by a is also not the inverse for multiplication operation. Since why? Since if a belongs to n, then minus a will not belong to the set n. So minus a does not exist in the set n. So minus a is not the additive inverse. Minus a is not the additive inverse. Uh, Also, you can see that 0, which is the identity for addition, does not belong to the set n. So 0 also does not belong to the set n, which is the identity for addition. So if we take the addition operation on the set n, then there is no identity also, identity for addition also. So there is no additive inverse also. There is no inverse for addition also. And also, if a belongs to the set n, then 1 by a does not belong to the set n. But here, 1 which is multiplicative identity, 1 which is multiplicative identity, that belongs to the set n. So 1 by a is not the multiplicative inverse. 1 by a is not the multiplicative inverse on the set n. Here also I should say minus a is not the additive inverse on the set n. Okay, so here here the in case of the multiplication operation, the multiplicative identity is there in the set n, but the multiplicative inverse is not there in the set n. So hope you have understood the concept for the how to find the inverse of an element with respect to a given binary operation. Thank you.